The Sun may appear to be the largest star in the sky, but that's just because it's the closest. On a stellar scale, it's really quite average. About half of the known stars are larger, half are smaller. The largest known star in the universe is UY Scuti, a hypergiant with a radius around 1,700 times larger than the Sun. And it's not alone in dwarfing Earth's dominant star. In this video, we'll check out NASA discovers a new unbelievable big star size comparison 2021. Before starting the video, please subscribe to the channel and click on the notification icon so you would get notified when we upload the next video. But first, a word on the stars. There are many different types of stars out there, some bigger, some smaller. Before going any further, however, you have to understand something. Stars don't have nice, tidy boundaries. They don't have a rigid surface like a rocky planet or moon. Instead, these atomic fireballs have pretty diffuse surfaces as the superheated mass of gas that makes them up slowly thins out into nothingness. What the astronomers use in lieu of a surface is a star's photosphere, the level at which the star becomes transparent. Example, where photons can escape the star. So going forward, know that if I mention a star's surface, I'm talking about its photosphere. The second important thing to keep in mind is that we haven't ever measured a star directly. Nobody went up there with a ruler and started adding up distances. What we do have are estimations, reliable estimations for the most part, but estimations nonetheless. Depending on a range of factors, such as distance or structures around the stars, or between them and Earth, these estimations can be more or less accurate and fall within a smaller or larger area of confidence. Example, we know it's between X and Y miles, kilometers wide. Smallest, Dunsest white dwarf. Astronomers may have discovered the smallest and heaviest white dwarf star ever seen. A smoldering ember about the size of our moon, but 450,000 times more massive than Earth, a new study finds. White dwarfs are usually about the size of Earth and are the cool, dim cores of dead stars that are left behind after an average-sized star have exhausted their fuel and shed their outer layers. Our Sun will someday become a white dwarf, as will about 97% of all stars. Although the Sun is alone in space without a stellar partner, many stars orbit around each other in pairs. If these binary stars are both less than 8 times the mass of the Sun, they will both evolve into white dwarfs over time. The newfound white dwarf, designated ZTF J1901 plus 1458, is located about 130 light-years from Earth and may be an example of what can happen when white dwarf pairs merge. If the white dwarfs were more massive, they would explode in a powerful thermonuclear explosion, known as a Type 1a supernova. However, if their combined masses fell below a certain threshold, they could form a new white dwarf heavier than either one of its parents, which is what scientists think happened in the case of ZTF J1901 plus 1458. Our discovery is the most massive and smallest white dwarf ever found. Study lead author Laura Sazio, an astrophysicist at the California Institute of Technology in Pasadena, told Space.com. The discovery was made by using the Zwicky Transient Facility at the Palomar Observatory in California, which scans the entire northern sky every 2 nights looking for cosmic bodies that blink, erupt, move, or similarly change in brightness. Study co-author Kevin Burge, an astrophysicist at the California Institute of Technology in Pasadena, first spotted the new white dwarf based on its high mass and rapid spin. The researchers used a host of telescopes to help analyze the dead star, which is about 100 million years old or less. These include the Hale Telescope at Palomar, the W.M. Keck Observatory's Keck 1 telescope, the European Geospace Observatory, and University of Hawaii's Pan-STARRS Panoramic Survey Telescope and Rapid Response System, and NASA's Neil Gehrels Swift Observatory. The scientists found that white dwarfs was about 2,670 miles, 4,300 kilometers wide, making it a bit larger than the Moon, which is about 2,158 miles, 3,474 kilometers in diameter. ZTF J1901 plus 1458's tiny size makes it the smallest known white dwarf, edging out previous record holders REJ0317-853 and WD1832 plus 089, which each have diameters of about 3,100 miles, 5,000 kilometers. At the same time, the newfound white dwarf is about 1.35 times the mass of our Sun, which may make it the most massive white dwarf discovered yet. The hottest WR102. While stars may not follow the exact ratio set by the quote from the 6th century BC, Chinese work Tao Te Ching, the gist holds true. The faster a star burns through its fuel, the shorter its lifespan. And this is surely the case for Wolf-Rayet stars. These stars not only burn incredibly hot and bright, but their stellar winds also blast much of their potential fuel into space. The hottest known star, WR102, is one such Wolf-Rayet, sporting a surface temperature more than 35 times hotter than the Sun. Like Baskin-Robbins, Wolf-Rayet stars come in a variety of flavors. The most massive star, RMC 136A1, has a spectacular type of WN, meaning it's rich in ionized nitrogen and a result of rapidly converting hydrogen to helium in its fiery core via the CNO cycle. However, the hottest star, WR102, is an especially rare WO type Wolf-Rayet, which is a late-stage star that has a surface heavily enriched with ionized oxygen. All said, astronomers only know of about 10 WO type Wolf-Rayet stars in the entire universe. Even for a Wolf-Rayet star, WR102 has intense stellar winds. Currently, they are blowing about a sun's worth of mass from the star's surface every 100,000 years. That means WR102 is losing several hundred million times more mass each year than the Sun. Although that may not seem like much for a massive star, keep in mind that at this rate, WR102 would be completely gone in less than 2 million years. But who can wait that long? Astronomers are interested in WR102 not just because of its exceptionally hellish surface temperature and rapid mass loss, but also because the star is a prime candidate to go supernova in the relatively near future. In a 2015 paper that explored how much time a variety of WO-type Wolf-Rayets have left before exploding as supernova, WR102 was found to have the worst prognosis. According to the authors, WR102 is a post-core helium-burning star and has a remaining lifetime of less than 2,000 years. Most massive star. At the top end of the scale, the most massive known star in the sky is R136A1, a star more than 300 times the mass of our Sun. And it's not alone in dwarfing Earth's dominant star. RMC 136A1, usually abbreviated as R136A1, lies about 1,630,000 light-years from Earth in the Tarantula Nebula. This massive star lies outside our galaxy. It's part of the Large Magellanic Cloud and one of the Milky Way's satellite galaxies. Astronomers working at the Radcliffe Observatory in South Africa first identified the star cluster in 1960, naming it RMC 136. When the Hubble Space Telescope examined the system, it found that the cluster was made up of more than 200 extremely bright stars. The most massive one was named RMC 136A1. R136A1 has an estimated mass of 315 solar masses, where a solar mass is equal to the mass of the Sun. Its mass when discovered was estimated at 265 solar masses, but further observations in 2016, with NASA's Hubble Space Telescope, refined the original measurements. Although this makes it the most massive known star, it was once even larger. Unlike humans, these stars are born heavy and lose weight as they age. Paul Crowther, a researcher at the University of Sheffield in England, told Space.com in 2010, being a little over 1 million years old, the most extreme star, R136A1, is already middle-aged and has undergone an intense weight loss program. Although R136A1 is the most massive known star, it is not the largest, since it only stretches about 30 times the radius of our Sun. The largest known star in UY Scuti, a hypergiant with a radius somewhere around 1,700 times larger than the Sun. Its mass, however, is only 30 times that of our nearest star. If R136A1 swapped places with the Sun, it would outshine our closest star as much as the Sun currently outshines the Moon. Its powerful radiation would have serious consequences for Earth. Its high mass would reduce the length of Earth's year to 3 weeks, and it would bathe the Earth in incredibly intense ultraviolet radiation, rendering life on our planet impossible, said Raphael Hirschai, a research team member from Keele University in England. Alpha Cygni. Deneb, also designated as Alpha Cygni, is a variable and double supergiant star in the constellation of Cygnus. Deneb visual magnitude is 1.25, making it the 18th brightest star in the sky. Thanks to its high brightness, Deneb is clearly visible when observed from locations with dark skies, and should also be quite easily visible from light-polluted areas. Deneb's distance is 3,227.72 light-years from the Sun and is moving towards the Sun at a speed of 5 kilometers per second. Deneb is almost twice as hot as our Sun, with an average temperatures estimated around 8.525 K. Deneb is around 19 times more massive than our Sun and has an incredible radius of 203 solar radii, and as such, a diameter of more than 200 times that of the Sun. Its absolute magnitude has been speculated to be around -8.38. Due to Earth axial precession, Deneb will become our northern star around the year 9800 AD. Deneb's spectrum has been used as one of the stable references by which other stars are classified since 1943. Though the star is massive, Deneb also loses much of its mass at around 100,000 times the Sun's rate of mass loss, or equivalent to almost one Earth mass per 500 years. Deneb is the most distant star out of the first 30 brightest stars in the night sky. Do share with us in the comments if you know more about stars in our universe. Thanks for watching.